Ever wondered how many hydrogen atoms are in just a few drops of water? Turns out 5 milliliters of pure water holds about 3.34 times 10 to the 23rd power hydrogen atoms. That's more than the number of stars in the galaxy. In this video, we'll show you how to calculate that using unit conversion and dimensional analysis. Step by step, no chemistry degree required. First, let's review a couple of key math rules to help us along. Multiplying by 1 doesn't change a number's value. This is called the multiplicative identity. When multiplying fractions, we can cancel matching terms in the numerator and denominator, including units. With that in mind, let's explore unit conversion and dimensional analysis. Dimensional analysis is a method used to convert values from one unit to another by applying conversion factors. You've likely done this before. For example, converting meters to centimeters, seconds to minutes, and others. A more concrete example is converting 10.00 US fluid ounces to milliliters, or going the other way, milliliters to US fluid ounces. To do this, we use conversion factors, which are ratios that express the same quantity in different units. These can be written as two fractions that we can use for our calculations. For example, converting 10.00 fluid ounces to milliliters involves multiplying by a conversion factor. Using our earlier math rule, the correct factor is the one that cancels the original unit and gives the unit we want. So, multiplying by 29.5735 milliliters per 1 fluid ounce gives us milliliters, which is correct, unlike something incorrect like 1 milliliter divided by 29.5735 milliliters. This example is a straightforward volume-to-volume conversion, but dimensional analysis also lets us convert between different types of measurements as long as we use the correct relationships. We can even chain multiple conversions together using the result of one step as the input for the next. Now, let's apply this to our original example. We start with 5.00 milliliters of water. Convert volume to mass using water's density of 1.00 grams per milliliter, assuming standard conditions. Now convert mass to moles using water's molar mass of 1 mole per 18.015 grams. Then use Avogadro's number 6.02, 2 times 10 to the 23rd molecules per mole. Each H2O molecule contains 2 hydrogen atoms, so use 2 atoms per molecule. Multiply and cancel units step by step, and you'll arrive at the answer of 3.34 times 10 to the power of 23 hydrogen atoms, rounded to 3 significant figures. Let's quickly recap. Dimensional analysis is a method that lets us convert between units by chaining together valid conversion factors. It works for both similar and different types of measurements as long as the relationships are accurate. The key is choosing conversion factors that cancel out existing units and leave you with the unit you want. And remember, this approach works best when you also watch your significant figures and check for realistic conditions, such as using appropriate densities and temperatures for the materials involved. Now that you've watched the video, let's see how much you remember. Head to the link in the description where you'll find Quizlet, content made just for you.